Okay, so we didn't have a vocab sheet for this unit because we don't have a whole lot of new vocab, but you did learn some new vocabulary. We've got exterior angles and we have remote interior angles. So I want you to go ahead and talk with your shoulder partner. What did you learn from that section that you read? What is an exterior angle and what is a remote interior angle? So and just turn with your shoulder partner or the person behind you. You guys can group up, even the four of you together if you'd like. Discuss what is an exterior angle and what is a remote interior angle. Feel free to draw a picture to help out if you need to. Alright, so today we're starting off with talking about different types of triangles, how we can classify triangles based upon their sides and based upon their angles. And then we also have some new theorems. Now, if you're one that likes to hole punch your stuff, I recommend holding off to the end of class because you'll be getting quite a few papers today. So you might want to just wait to the end and then take that all together. Now again, ideally this should look familiar based upon your reading that you did. Like, oh, this is so easy. Not at all. Alright, is there anyone that did not get the minutes? Alright, so first of all, we're going to take, again, a look at our different types of triangles based upon sides and based upon angles. So we're kind of doing some vocab with this. This is vocab that you're familiar with from your elementary days, but we're going to go ahead and kind of define it properly. Alright. So we have three different types of triangles based upon our sides. Alright, so think back to elementary school. What is one type of triangle I have based upon its sides? Right triangle, that's actually one of our angles, so let's go and put it over here. Because how do I know if I have a right triangle? What is a right triangle? Come on, guys, I know you know this. Yes, Jimmy.
It's a triangle that has one right angle.
Good, it has one right angle on it. So we know that based upon one of its angles. So a right triangle, we have one angle is 90 degrees. It's a right angle. Alright, now, can I have a triangle have more than one 90-degree angle? Can I have two angles be 90 degrees? No. Why not? Go ahead. Yeah, you need three angles. You would need more than three sides. So a triangle is three angles. How many total degrees are there within a triangle? 180, and that's our triangle angle sum theorem. The sum of the measures of the angles of a triangle is 180 degrees. So if I had two angles, each 90, then I've got 0 degrees left for that third angle, and thus we don't have a third angle. So I can only have maximum of one angle be 90 degrees. So right triangle, one angle is 90 degrees. Alright, so that's one of our types of triangles based upon the angles. Let's try again for another one based upon sides. Think of your different types of triangles.
Equilateral?
Equilateral, very good. What is an equilateral triangle?
All three of the sides are the same.
Good. So equilateral triangle, we have all sides are the same. So all sides are equal. The measures of each of the sides are the same. Right. So good. That means all three of the sides are the same. What's another kind that we have? Go ahead. Isosceles. And what is an isosceles triangle? Good. And in geometry, actually, we're a little more specific than we were in elementary school. So in geometry, at least two sides are equal. So at least two sides are equal. So if I'm saying at least two sides, could I classify an equilateral as an isosceles? Is an equilateral an isosceles? Yeah, because equilateral has three sides equal. Now, when we're classifying, we're going to go with the most specific that we can get, meaning that if it's equilateral, if all three sides are the same, we're going to call it equilateral, not isosceles, just because we want to go as specific as we can. But that's good to know that equilateral triangles are isosceles triangles. I think that right. Okay, can we figure out what the third one is basically? That all three are the same. Two sides are the same. Scalene, my particular favorite. So we have scalene triangle. And what is a scalene triangle? I don't know what a scalene triangle is. Good, none of the sides are equal, so no sides are equal. Okay, so equilateral, all are the same. Isosceles, at least two are the same. Scalene, none of them have the same length. Good. Raise your hand if all three of these words you have seen before in your life. Good, good, good. Okay, so now let's take a look at it based upon angle. So my first one is a right triangle, as Anthony said, and we have one angle is 90 degrees. What other types of triangles do I have based upon the angles?
Obtuse.
Good, obtuse. So I have an obtuse triangle. And what makes an obtuse triangle obtuse? Good. So we have one angle. I'm going to write out the word angle. One angle is greater than 90 degrees. Okay, so one angle is greater than 90 degrees. Can I have two angles be bigger than 90 degrees? No. Again, I get over that 180 degrees with that. All right, and then what's my last one? Good, acute. And what is an acute angle? Or an acute triangle, sorry. Good. So for an acute triangle, an acute angle, we know it means it's less than 90 degrees. An acute triangle is defined as all angles are less than 90 degrees. So all angles are less than 90 degrees. I want you to turn and talk with the person behind you. Why do we have to say all angles rather than just one angle? Here I have one angle is 90, one angle is greater than 90. Here I have all angles. Turn and talk to that person behind you. Why does it have to be all angles?
We can't be 50%. I mean, that wouldn't be.
Alright, anyone brave enough they want to say why it has to be all of the angles? Go.
Because if it was only like one or two, then it could be like two triangles.
Right, yeah. Both my right angle and my obtuse angles, or my right triangle and my obtuse triangle, leaves only enough for the remaining two angles to be acute. So what makes it acute is that every single one of them is less than 90. Very good. Okay. So we already talked about our triangle angle sum theorem. The sum of the measures of the angles of a triangle is 180, so all the angles inside a triangle have to be 180. Now our third angle theorem. Alright. If two angles of one triangle are congruent to two angles of another triangle, Okay, if two angles of one triangle are congruent to two angles of another triangle, then the third angles are congruent. And the third angles are congruent. Okay, so let's draw the picture, please. I'm not sure why it's not letting me do the different colors. That's why I pick up the different. Alright, these are not drawn to scale. But let's suppose that this is let's not go equal hour. Let's just go 50, 30. You can never trust the picture, right? Never trust the picture. And let's say that this one has here. And alright. So this theorem says if two angles of one triangle are congruent to two angles of another triangle. So we have our 30 is congruent and our 50 is congruent. Then the third angles are also congruent. So what that's saying is that this last angle must also be congruent. So let's see if that makes sense with our example we have here. If I have 50 and 30, how much must this last angle be? 100. Good, 100. Although it might not look like it, it's 100 degrees. And likewise down here, if I have 30 and 50, how much must that last one be? 100. It's kind of like that congruent supplements theorem. They add up to be the same amount, and they are the same values, so that leftover amount must be the same. My angles are the same, and they both add up to be 180, so the leftover amount must be the same. Okay, so that's our third angle theorem. If I know that the two other angles are congruent, that third angle must be congruent. Any questions on that? Okay. So then we also have our triangle exterior angle theorem, and this is what you had to use with your homework last night, what you read about and used. The measure of each exterior angle of a triangle is equal to the sum of the measure, or the measures, the sum of the measures of the two remote interior angles. Remote interior angles. Okay, so this is my triangle exterior angle theorem. The measure of each exterior angle is equal to the sum of the measures of the two remote interior angles. Now I made you talk with your shoulder partner about what exterior and remote interior angle is. So let's go ahead and use this picture down here to kind of classify it. We're going to go and label the angles. We have angle 1, and let's just go around. Angle 2, angle 3, and angle 4. In our triangle here. We can see that one of our sides has been extended. Now I can extend any of my sides, and I actually could extend this in either direction. It could have extended it this way as well, and had my angle 1 be there. Which makes sense because those would be the same, they're vertical angles. Okay. So on this picture, which angle is my exterior angle? Go ahead, Noah. 1. Good. So angle 1 is an exterior angle. Okay. Now, if 1 is my current exterior angle, it has corresponding with it two remote interior angles. And again, this is going to change depending on which exterior angle we are talking about. So if 1 is an exterior angle, then which two angles are my remote interior angles? Which two angles are my remote interior? Go ahead and share with your shoulder partner real quick which two are the remote interior. Alright, which two are my remote interior angles? Good, everyone. Good, 3 and 4. So my remote interior angles are angle 3 and angle 4. Good. So my exterior angle, its corresponding remote interior are basically the two that are not a linear pair with it. So what this theorem tells me is that the measure of angle 1 is actually made up of the measure of angle 3 plus the measure of angle 4. Which you're like, that's nice, but Mrs. Margraf, if I know angle 2, then I can figure out angle 1. If I know angle 2, what do I use to find angle 1? How can I find angle 3? Yeah, they're linear pairs, and from the linear pair postulate, we know linear pairs are supplementary. So we know these add up to be 180. Alright, but we're not always given that information there. We might have a situation in which we only have 1, 3, and 4. And this is another way to then find that angle 1. Or we might only have 3. Alright. I want you to turn and talk with your shoulder partner about why this is true. How can I state that measure of angle 1 is just the angle 3 and 4 added together? How do I know that's true? Think of what we know about our triangle angle sum theorem as well as what we know about linear pairs. Right? So then take about a minute, talk with your shoulder partner about how we can know this theorem is true. If we were asked to prove it, what would you do perhaps to prove it? All right. Okay. Anyone want to go and share what they said? And we're all scared of it, aren't we? It's like everyone, you're scared to talk. All right. Give me one thought with it. Just one thought. You don't tell me the whole thing. Just one thought, please. Good. Awesome. So she found those connecting ideas. Elise said that the measures of the angles in my triangle add up to be 180. And my linear pair is supplementary, which means it adds up to be 180. So couldn't we use the linear pair postulate to say that angle 1 and angle 2 are sub? Do you guys agree with that? Yeah. All right. And then from here, couldn't I say that the measure of angle 1 plus the measure of angle 2 equals 180 degrees? Do you agree with that? What's my reasoning for that statement? Ooh, what would be the reasoning out of that, Vincent?
Linear pairs.
Linear pair postulate lets me say that they're supplementary, but what lets me go from saying that they're supplementary to say their measures actually 180?
Definition of supplementary.
Very good, definition of supplementary. Okay. So we agree with this statement. Now separately, we could say that the measure of angle 2 plus the measure of angle 3 plus the measure of angle 4 equals 180. Do we agree with that? Who knows what my reasoning would be for that one, though? Anthony? Not definition of triangle, but you're on the right track. Our triangle angle sum theorem, that theorem that we just learned, is what lets me say that their measures add up to be 180. Does that make sense there? Okay. All right. So then from here, if I could, look at that. They are both equal to 180, so I could go ahead and set those equal to each other. All right. So I have the measure of angle 1 plus the measure of angle 2 equals 180, which equals the measure of angle 2 plus the measure of angle 3 plus, if I can squeeze in here, the measure of angle 4. Do you guys agree with that? What would be my reasoning for that one? Substitution or transitive, very good. Then what would I do from here? What can I do with this statement, this equation? angle 2. So the measure of angle 1 equals the measure of angle 3 plus the measure of angle 4. Lo and behold, that's exactly what my triangle exterior angle theorem says. So we just verbally proved that theorem there. Very good. All right. You might be asked to do that at some point in time. Could be on a quiz, could be on a test, could just be on your phone. But we should be pretty good. All right. Any questions on what we have learned so far? All right. So next, we just have some practice problems dealing with this. So this first one says find the missing angle of each triangle and then classify it 2 different ways. Okay, so when it says classify 2 different ways, we mean classify it based upon its angles and classify it based upon its sides. Remember, we want to get as precise as we can. So for example, for my first one here, we have 60, 60. What's my last degree going to be? 60 degrees. All right. So if every single degree is 60 degrees, what type of triangle is this based upon its angles? Acute. Good. I'm going to put my angle 1. Every single degree is acute, so thus we call it an acute triangle. Now, does anyone know what type of triangle this is based upon its sides? Go ahead. Equilateral. Very good. Equilateral. Equilateral. Okay. Now I want to go ahead and squeeze this in. Well, we can just squeeze it at the top. Equilateral triangles are equiangular. Equilateral triangles are equiangular. What do you think equiangular means? Go ahead, Scott.
Same angles?
Yeah, they all have the same angles. So what we saw there was that it was 60, 60, 60. Those were acute, 3 acute angles, all the same thing. So if all 3 angles are the same measure, then it's an equilateral triangle. So if we stop and think about this, if my triangle angle sum theorem says that the measure of any triangle's angles is 180, then what we can find is that my equilateral triangle will always have to be 60-degree measures. Because there's 3 angles, they have to be the same. 180 divided by 3 is 60. So equilateral triangles are always equiangular, which then for this specific shape, we have that specific. Good. Okay, so I want you to go ahead and go through. Yeah, I think you can try these. I want you to do we did A through D, and then try just this first one here. All right, so go and try this individually. Find that remaining angle, classify it based upon its sides and its angles, and then go ahead and try to solve for A, B, C, angles A, B, C down here, using that triangle exterior angle theorem. Go and do that individually, start second. Give you just a few more seconds to finish that up. All right, I want you to go ahead and compare what you got for those with your shoulder partners. See if you got the same thing. If you got different answers, talk about it. See what you guys did different. All right, let's see how we did. All right, so for letter B, what was my remaining angle? 20, do we agree? All right, and so we should have had then seen that this is perhaps, or seen that this is my largest angle here. I can go and call this obtuse. What type of triangle is it based on its sides? Go ahead. Isosceles. How did you know that? Good. Two of my angles are the same, and we're kind of foreshadowing to what we're going to be learning a little bit later. But since two of my angles are the same, the sides opposite will be the same. Good. All right. C. What did I get from my remaining angles here? Oh, you guys are all looking at me funny. What's the problem with C?
It's more than what you need.
Yeah, when I add up 60 and 160, what do we get? Yikes! So this is not a triangle. It cannot possibly give us a triangle. I'm not sure what it is. Is it just two angles of a larger polygon? Is it just two angles in there? Not sure, but it is not a triangle. So can't find the remaining angle, can't find the sides. Very good. All right, and then D, what did we get for our last angle here? 60, good. So, what type is this based on our angles? Go ahead, Mom. A cube, good. None of them are larger than 90 degrees. And what is it based on upon my sides? Go ahead. Scale. Alright, questions on A through D? Alright, now when we go to find the measure of each angle down here, we have to use a combination of the triangle angle sum theorem and our triangle exterior angle theorem. So first, let's go ahead and find angle C. What did you guys get for the measure of angle C? 87, do we agree? I got one. Does anyone else agree? Good. All right, now check your answers. Did you write measure of angle C? Not change that. Because by saying angle C equals 87 degrees, that's not proper notation. So measure of angle C, and then check, did you write equals? Because we don't use congruency when we're talking about the actual measurement. That would be the lazy man's way. Go ahead and write it out with proper notation here. Good question, though. Thank you for asking. All right, so we've got angle C is 87 degrees. Now, what do I get for the measure of angle B? What do we get for that? Go ahead, Vincent.
93 degrees.
93 degrees. And, ooh, let's do some cold calling since some of you guys are just going to sit there sleeping the whole time. Matthew, how did I find the measure of angle B? linear pair with C, so I can do 180 minus 87. How else did I know that this was 93 degrees? What else could I have done? Go ahead, Mom.
You could add up the 42 and 51.
Good. 42 and 51 are my exterior my remote interior angles that go with B. So I can just add those up without even knowing angle C. I can know angle B. Good. All right, and then finally, what did we get for angle A? What's my measure of angle A? 8. What'd you get for measure of angle A?
Wow.
Or George is going to help you out.
58.
58. Do we agree 58? Close. 59? Good. 59. Measure of angle A is 59 degrees. And Sam, can you explain for us how we get that?
Angle A plus B plus equals this sum.
Good. We know that this is a triangle by itself, so that these three measures have to add up to be 180. So I know then, I know B, so I can add up 20. Is that 28?
Yeah.
It's hard to see here. Hard to see on your guys' paper too. 28 and B, and then subtract that from 80. Good. Anybody see another way that we could find this, Ginger?
We could add up 28 and 42 and 51.
Very good, very good. We also have that this is just one big hunkin' triangle here. So I could add these together plus this guy and then subtract that from 180. Very good, very good. All right, other questions on these parts that we've done so far? Okay, so let's go take a look at this next one. It says, again, find the measure of each angle, and we've got 1/2 x plus 4. Rewrite that here. This is my expression for this angle here. And then we have 1/2 x minus 10. Are these angles the same? No, I do not have any information that tells me they're the same. Okay, so it's really important. That's a common mistake I see. Is that just because, well, what does this notation mean? Yeah, 90 degrees. So this is a right triangle. Right triangles do not always have congruent acute angles, okay? So it's really important. In fact, we have an entire unit on special right triangles. A 30, 60, 90, and a 45, 45, 90 triangle has special properties. So do not assume that these are each 45 degrees apiece, okay? They are not equal unless they tell you or give you some type of marking to indicate that they are the same. All right, I want you to go ahead and solve for this real quick. Solve for x, and then the instructions say find the measure of each angle. So go and do that real quick. Give you about a minute and a half for that. And then we'll go over that one. All right, when we solved, what did we get for x? (96 degrees). Do we agree? Very good. All right, do you agree with my setup here? I did a little bit extra work. Instead of saying these two plus 90 equals 180, I went ahead and recognized, well, if this is 90, I only have 90 degrees left, and so I set it that way. That's fine. You're using that triangle angle sum theorem with an additional subtraction step. Okay, x is 96 degrees, so what do I have for this angle? Measure of this angle, what is that? Good, 52, and Anthony, go and give me that other one. 38? Do we agree with this? Very good. All right, now this last one, it says the ratio of the angle measure of the acute angles in a right triangle is 2 to 3. What are the acute angles? Yikes, that sounds interesting. The ratio of the angle measure of the acute angles in a right triangle is 2 to 3. So we're going to throw it back to middle school with our ratios. I think for this type of picture, it's usually helpful just go ahead, this type of problem, it's helpful to draw a picture. So go ahead and draw a triangle however you want. Doesn't matter if it's accurate in its representation. And they tell us, they tell us it's a right triangle. I'm going to try to make it look a little more like a right triangle. Again, your picture doesn't have to be exact. But they tell us that the ratio of the angle measure of the acute angles is 2 to 3. These are my acute angles. So if I were to take those measures and simplify it down in a ratio, it would simplify down to 2 to 3. That doesn't necessarily mean that it's 2 degrees and 3 degrees. In fact, it cannot be 2 degrees and 3 degrees, because then it wouldn't add up to be 180. But we've got to find what ratio would simplify down to that. Alright, so what we're going to do to help us solve for this is, I'm going to call this angle 2x, and this angle 3x. 2x and 3x. Now let's talk about why we do that. A ratio. Who can explain to me what a ratio is? If I'm saying the ratio of my two angles here, what is a ratio? Go and talk with your shoulder partner. What is a ratio? What does a ratio do? Dig deep into those middle school brains. Okay, does anyone want to go ahead and give it a shot? What is a ratio? No one feels brave enough for this one. Would you agree a ratio is a comparison of two values? Comparison of two values. So I'm comparing this angle to this angle, 2x to 3x, whatever value it may be, I'm comparing those. Now we know that we can write a ratio as a colon. How else can I write a ratio? Good, a fraction. So I could say that this is the same thing as 2 to 3. Would you agree with that? Okay. So the reason why I'm doing this here is because I know that my angle is not just 2 degrees and 3 degrees. That obviously gives me the 2/3 ratio. Now we could up it a little bit. Would you agree that 4 to 6 would give me that same ratio? Or 20 to 30 would give me that same ratio? Now what that's doing is simply taking my values here. So for example, the 4 to 6, I just simply multiplied it by 2 each time, right? I have 2 times 2 and 3 times 2. Or the 20 to 30, I just simply multiplied it by 10 each time. You're multiplying it by the same value because you want it to reduce down to 2/3. So if I compare these, 2x to 3x, would you agree that my x's reduce and I'm left with just 2/3? Would you agree with that? That those fractions are equivalent? So we need to solve what those angles actually are. We go ahead and throw an x to represent that unknown amount that I'm multiplying by. Because I know it's got to be more than just 2 and 3, or even more than 20 and 30, because that's only 50 degrees, but we need to get up to the 90. So now we can use these to help us set up an equation here. So now if I go and set this up, 2x plus 3x equals what? What does 2x plus 3x have to be? 90, good. Now again, we could go ahead and say 2x plus 3x plus 90 equals 180, but we're going ahead and say that sometime. So Bree, what do we have to do from here? Slash get off that. What do we do from here? 2x plus 3x equals 90. What can I do? Good. So we get 5x equals 90. All right. And we're going to have to do a little bit of math here. Divide by 5. Divide by 5. Get this guy out of my way. All right. So we have then x equals 5 goes into 9 one time. That would leave 4 left over. 5 goes into 40 how many times? 8. So x is 18. Now that's not my answer. They asked for what are the acute angles. So go ahead and put that back in and find my two acute angles here. What do we get? Take about 10 seconds. Put that back in. Alright, what are my two angle measures? Go ahead.
36 and 54.
36 degrees and 54 degrees. Alright, do we agree with that? Okay. And if I went ahead and did 36 over 54, I could reduce each one by 18 and it would come down to 2/3. So you can always double check here. Alright, that's the easy stuff for today. Let's take a look at the next piece, which is still easy, but it's and this is kind of the foundation for what we're looking next, the building blocks for the next week. Alright, so now what this unit is, it's an extremely important unit for geometry. In fact, this continues, the topic or the information from here continues to creep back up into almost every single unit from here. So what we're learning about in this unit is congruent triangles. What are the properties of congruent triangles? What fancy things do we know based upon two triangles being congruent? So congruent triangles, if the shape is congruent, then that means it's the same shape and the same size. Alright, so for congruent, if I have two triangles that are congruent, so like if I said triangle ABC is congruent to triangle XYZ, that means it's the same shape, so they're both triangles. And it's the same size, which means my sides that correspond are the same. And my angles that correspond are the same. We can branch this out to just congruent polygons in general, so let's just go and write this off to the side. So congruent polygons congruent polygons have corresponding sides congruent and corresponding angles congruent. So that means the sides that go together are the same length and the angles that go together are the same measure. Okay, so if I had congruent pentagons, that means that their corresponding sides, the sides that go together, are the same length. Not necessarily that all of 5 sides are the same, but that sides that go together are the same. Alright guys, I need your heads up off the desks. That's not okay in this class. Alright. Corresponding parts of congruent triangles are congruent. This is huge. This is vital to this chapter here. And we get to abbreviate this as CPCTC. Corresponding parts of congruent triangles are congruent. This is a huge idea for this chapter. What this says is if I have two triangles that are congruent, then I can say that their corresponding parts are also congruent. Okay, so I have to be given that these two triangles are congruent. Then from here, I can identify each of the corresponding pieces as congruent. So if I was given that triangle ABC is congruent to triangle XYZ, then I can say that angle A is congruent to angle X. Angle B is congruent to angle Y. Angle C is congruent to angle Z. Now, a lot of times we're given pictures in which we can match up the information. But from just the statement alone, I can find my corresponding pieces. So that's just the angles. From here, we also have our sides. Side AB, so segment AB, is congruent to segment XY, or side XY. The order in which this is listed is important, because your corresponding pieces have to go together. Likewise, BC, side BC is congruent to side YZ. And then my last side, AC, is congruent to my last side, XZ. Notice how I'm keeping the pieces together. It matters what order because A goes with X, angle B goes with Y, angle C goes with Z. If I were to draw a picture of this, I have A, B, C, X, Y, Z. Then I could go ahead and fill in the information. A and X have the same angle measure. B and Y have the same angle measure. C and Z have the same angle measure. AB is the same as XY. BC is the same as YZ. And last, AC is the same as XC. Now I can fill in all this information. This information might be given to me. But in order for two triangles to be congruent, all of their corresponding pieces have to be congruent. Likewise, if I have all of their corresponding pieces are congruent, that means the two triangles are congruent. Now, the thing is, that's a lot to show. That's 6 different pieces of information that have to be congruent in order for the triangles to be congruent. And what we have found in geometry is that you don't actually have to show all 6 pieces. There are certain cases that we show in which it's sufficient to show all the pieces of the same. And that's what we'll be learning about next class. Today what we're focusing on is just simply identifying how to match up these triangles. Okay, so it's really important again that you get that order correct. Now, if I were to ever ask you to name the corresponding pieces, this is what I'm looking for. The 6 pieces of information, the 3 sets of angles and 3 sets of sides that are between the two. Alright. So we're just going to, for today, take a look at kind of just how to write out these statements. Alright. Now here the pictures are real nice where it's easy to see what matches up. That's not always going to be the case. They could take the triangle, they could flip it, they could turn it, they could rotate it. So they'll often have markings on the triangles to help you kind of match it up. Now these ones are drawn real nicely where it's easy to see what matches up. So here we have triangle ABC is congruent to triangle XYZ. Again, I could go through and draw in my corresponding pieces. All of my angles, corresponding angles are the same. Corresponding sides are the same. Thus I have all 6 pieces. Now notice, it's not that all 3 sides are the same. These could be 3 different side lengths. But A and B and X and Y have that same measure. Alright, so then here I have triangle RTQ. This is congruent to triangle, and you gotta be careful with this, RTQ LKN. LKN. I can see that these angles go together. So in my statement, I need to make sure that T and K are in the same location. Likewise, I can see that R and L go together. So R and L need to be in the same location on my statement. And then finally, I can see that Q and N go together. So again, they need to be in the same location. I want you to fill in that last one, see what you get for it. Go ahead and compare your answer that you got. Make sure you have the same order as your shoulder part. The letters have to be together. No, we're not going to have Guys, your homework that you did for today, that top one that says read section 3 25 in the textbook. We're not going to check it for today, so you can just put an X in that box to help you know that you did not miss a signature for it. Alright, what did we get for our congruency statement here? Triangle THR is congruent to triangle what? Go ahead, Anthony. XYW. Raise your hand if you agree with that. Okay, let's see. Very good. So again, we can see that these angle measures went together. So again, in my statement, those need to go together. Likewise, these went together. And then the last piece. Okay, so again, next class we're going to be talking about how can I know from the diagram or from information given to me if the triangles are congruent without having to show all 6 pieces. Okay, so what I passed out to you is worksheet 1. I want to take a look at something with this first before we get going on. This is just classwork for today just to give us some more practice with it. So it says for exercises 1 through 7, refer to the figure at the right. Triangle ABC is isosceles, and then they give some information, and also those lines of parallel. Now, before we go into this, I want to go ahead and talk a little bit more about the structure of an isosceles triangle. Because that's from elementary school, 2 sides have to be the same. As we talked about, more specifically, at least 2 sides have to be the same. Let's talk about the pieces of your isosceles triangle. So just write this up in the corner here. Go ahead and draw yourself a nice isosceles triangle. As best as you can. Okay, so this is isosceles. Okay. I think I have an extra C there. Isosceles. Alright, so isosceles triangle, the 2 sides that are the same length, we'll go ahead and make it with this notation. Those 2 sides we call our legs. So this is a leg, and this is a leg. Okay, so the 2 sides that are the same length we call our legs. Anyone know what that remaining 3rd side we call?
Base.
Very good, our base. Now again, that isosceles triangle can be turned all around, flipped upside down. Okay, so the 2 sides are the same as our leg, and then the bottom one is our base. Now let's talk about the angles. So these 2 angles here that are along my base, we call our base angles. Base angles. So these 2 angles here are our base angles. Does anyone know what this top one is called? Yeah, very good, very good. Vertex. So the angle that's made up of our 2 legs coming together at a point, that's our vertex. Okay. Alright. So you're going to need that information to help you identify some of that. So on the front side, just working a little bit with identifying information. On the back side is where we actually have that we're using what we learned. We're using what we've learned today with exterior angles and the sum of the interior angles to find x. Okay. I'm going to go ahead and pair you up and then have you work with your partner on this worksheet here. So give me just a moment and I'll go ahead and get that paired up. While you're waiting for me to pair up, go ahead and actually just work on that first part 1 through 7 where you're identifying the pieces, and then you can compare that with your partner once you get together.